So good morning. We've obviously all just received the news about the whole virtual learning environment thing. Look at the smiling faces that we can see around. Let's have a look, let's pan around. See all these smiling faces? Yeah. Isn't it crazy that there's a viral epidemic out there and people are smiling? So today, what are we going to be talking about? Well, the lesson really is being recorded for the benefit of those who are not here today. So big shout out to August, to Zara. Who we shout out? We shout out Izzy Christian, and who else are we shouting out to? Izzy Thompson. Fantastic. So we're sending big love to you all out there. We are going today we are going to be talking a little bit more about alcohols. Fantastic. We're also going to be talking a little bit more about carboxylic acid, and we're also going to be talking a little bit more about what happens when a carboxylic acid and an alcohol react together. But before we do that, I think it's really important that you take a look at the board from last lesson, if you missed last lesson for whatever reason, which has kind of a breakdown of all the alkanes, alkenes, and how they, through a process of either hydration or, in the case of producing a carboxylic acid, oxidation, turn into alcohols and carboxylic acids, respectively. So I'll give you a moment just to do that. Back in a second. This is a photograph of the board from last time, and I hope you've had a moment to sort of digest this over the course of the last couple of days. It focuses on the alkanes, the saturated hydrocarbons. It also focuses on the alkenes, the unsaturated hydrocarbons. And it also talks a little bit about alcohols, which are formed from the hydration of alkenes in the presence of steam and a phosphoric acid catalyst. If you want to know a little bit more about these, page 287 of the textbook is really, really helpful with regard to that. And they also go on to talk a little bit about further oxidation of the alcohols to form carboxylic acids in the presence of a dichromate catalyst. But that might need a little bit of reading, a little bit of research from pages sort of 287 onwards. Take a look at that before next time. What we're going to do now is we're going to have a look at some alcohol. So if somebody could throw me an alcohol, thank you very much. Oh, there's an alcohol, good stuff, thank you. Fantastic. So we have got here, we've got some examples of some alcohols, and hopefully you can see that these are alcohols because they are no longer hydrocarbons. Quick questions. How do we describe a hydrocarbon? Yeah.
A molecule that contains hydrogen and carbon
only carbon and hydrogen. As you can see here, carbon, hydrogen, and oxygen. So therefore, this is not a hydrocarbon. This is an example of an alcohol. And we know that it is an alcohol because of this bit here. What is that representing there? Does anybody know? Yeah, what was that, Josh? A hydroxide. We've got an oxygen and a hydrogen. So what we're saying is that the alcohols are homologous series, which in addition to having carbon and hydrogen, also have this characteristic OH group. So there's an example of one. I gave everyone an opportunity to make whichever one they wanted. Whose was this? Lissy, yeah? Do you know what name we would give to this particular alcohol?
Butanol.
We would call it butanols. And if you're puzzling over why it might be butanol, well, 1, 2, 3, 4 carbons. Monkeys eat peanut butter. B for butter is butane. So because it's butane but with an OH group, we call it butanol. We could actually go one step further there, and we could say this is called butan-1-ol. Does anybody know why we might call it butan-1-ol? Emily?
What's the red again?
Oxygen.
Oxygen is on the first.
Yeah, the oxygen or the OH group here is attached on the first carbon. Fantastic. So if we number these 1, 2, 3, 4, we can see here that we've got butan-1-ol. Fantastic. We're going to leave that for a moment. We're going to look at this slightly smaller molecule. Ruff, ruff. Looks like a little doggy. Obviously, that's had its back legs amputated. Not appropriate. So we'll cut that out in the edit. So with that in mind, anyone know what we're going to call this alcohol? Hands, please. Yeah, Mr. Bezic.
Methanol.
We call it methanol. Do we need the one? Methan-1-ol?
No.
Why not?
There's only one carbon.
There's only one carbon. Fantastic. Can I have your alcohol, please? Fantastic. That's great. Oh, awesome. What about this one? Would we call this what would we call this?
Ethanol.
Ethanol. Ethan-1-ol?
Ethan-2-ol.
Ethan-2-ol. What about now?
Yeah, it's always one of. It's always one.
It's always 1-ol. Fantastic. So the only time that we get to it, did anyone make propanol? That would be amazing if you did.
There wasn't enough.
There's only 4 carbons.
What, somebody got 4.
Yeah,
That's
you
good.
can
There
make
was
3.
only 4.
Okay, fair enough. So we've got, as you can see, butan 1-ol. It's got a number because it's long enough to have a number. This one here, we've got methanol, and there we've got ethanol. Fantastic. So those are some examples of some alcohols. Any questions about alcohols? Any questions at home? No, maybe not. Okay, fantastic. So with that in mind, let's leave alcohols for a moment and let's have a look now at some carboxylic acids. Fantastic. So we're back now with carboxylic acids. Who's got carboxylic acid for me? Fantastic, thank you very much. Who else has got another one? Another one? Same one, that's okay, we'll take that one. Fantastic, thank you, tremendous. Fantastic. Ooh! This carboxylic acid's had a bit of a funny turn. Why is this? What can we see here?
It's got a missing.
It's got a missing bond, so that can't be right. Fantastic. Now, what actually is really interesting here, and if we take back our methanol that we had here a moment, is I can quickly turn this carboxylic acid by just adding this OH. We've got to remember that in addition to the carbon to oxygen double bond that we have here between this carbon and this oxygen, we also need to remember that OH group. So here we have 2 examples. Fantastic. In fact, what I'm going to do is I'm going to just butcher this one a second. Fantastic. We've got 2 different now carboxylic acid. This one's looks like a dog that's just caught a ball. Fantastic. So with this in mind, any ideas what we might call this? This is called ethanoic acid. Fantastic. So that is ethanoic acid. What about this one? Propanoic acid. Fantastic. So we, as you can see here, we've got some examples of some carboxylic acids where we can see this characteristic carbon to oxygen double bond, and here we've also attached to the same carbon as the carbon to oxygen double bond, we've got an OH group. We can see that there, and we can also see that there. The reason why that's called ethanoic acid is because it's got 2 carbons, monkeys eat, ethanoic acid, and here we call this propanoic acid because it contains 1, 2, 3. Any questions about carboxylic acids now? Fantastic. We're going to see how these 2 bad boys react in just a second. Fantastic. So what we've done now, and hopefully you can see that here, is we've taken our model and converted our model into a displayed formula. And hopefully what you can see here is that these lines here are representing covalent bonds. Stay with me, sister. With covalent bonds, carbon to hydrogen, carbon to oxygen bond here. Fantastic. So this particular display formula is one of ethanol. Fantastic. So, using the same idea, we've got our carboxylic acid. This is the carboxylic acid we were just talking about a few moments ago. Just remind me what this is called.
Ethanoic acid.
Ethanoic acid. So this is ethanoic acid, and what we've tried to do here is we've tried to, let me just flip that over so we can maybe see it a little bit more in relation to the displayed formula I've drawn here. We can see hopefully that we've got our carbon to carbon, we've got this carbon to oxygen double bond which is represented here, and we've also got this OH which is down here. So this is now how we would draw the displayed formula of a carboxylic acid. Everyone happy with that? Fantastic. So what we're going to do now is we're going to take our alcohol, which is ethanol, and we're going to take our carboxylic acid, which is ethanoic acid, and we're going to add those 2 materials together in an effort to generate a compound that is called an ester. Let's first of all consider it using the molecular models. What we need to recognize is that alcohol, ethanol in particular, is present in various alcohols like wines or spirits or whatever. What we need to recognize is that over time these oxidize and turn into carboxylic acids. And what's really interesting is that what happens when these alcohols and these carboxylic acids combine. Well, what happens is really, really interesting. So, in essence, a bond breaks here, and a bond breaks here, and these materials combine to form water. We generate a water molecule. And what happens here is this species turns over until we end up with a species that looks a little bit like this. Now this molecule, because of the carbon to oxygen double bond, the carbon to oxygen and then oxygen to carbon linkage, that sequence of bond leads to a compound called an ester. Now esters form the basis of all smelling molecules in organic chemistry, and that's what gives the wine its smell. That is what gives some of the alcohols their smell, because of the presence of these esters. These esters are also the principal components in perfumes. So when you're using your CK1, maybe you don't squirt it under your armpits, on your neck or whatever, or you rub it together on the hot spots on your wrists, we are using esters to generate that smell. So we're going to look at that from a molecular model. We've looked at that from a molecular model perspective. We're going to try and then convert that into a displayed formula diagram. So we've come up to the board here. We're writing in our purple books, just making a few notes with regard to what we've discussed over in the back there. What we've got here, making esters. So esters are made when alcohols, we mentioned the alcohols, react with the carboxylic acids. The OH group on the alcohol, that's this bit here, reacts with the sort of the COOH. It's a little bit disorientating here, but we've got the COOH group of the acid. And effectively what's going to happen during the course of this reaction is effectively this is going to react to produce a water molecule. Now, can anybody remember what name we gave to this process where we produce this kind of water during this process? Say again? We call it condensation. So sometimes we describe this reaction as a condensation reaction for that very reason. But now what we need to do as we look at this is we need to see now that this carbon is now linked via this oxygen directly to the carbon which is attached to the carbon-oxygen double bond. So drawing this structure out, what we can see here is we've got our carbon chain from the alcohol, which is bonded to the oxygen, bonded directly to the carbon, which is attached to the oxygen with the double bond. And then, of course, we've got the remaining carbons all attached to hydrogens. So as we write in the statement here that they combine to form the COOC linkage. And this is the COOC linkage that we're talking about here. Now that linkage we call an ester linkage. And it happens through this condensation. Sometimes we call it an esterification reaction or esterification. In the exam they could use either of these terms, so it's important that we know what it is called. Now the final thing that I want to discuss is I want to talk a little bit about the names that we would give to these substances. And what we do is we name them dependent on the alcohol and the acid that we use. And how we do that is we recognize that this is made from ethanol, so we call it ethyl. And because it's made from ethanoic acid, we call it ethanoate. So the ethyl comes from the alcohol, whilst the ethanoate comes from the acid. So ethyl ethanoate would be the name of this. We're going to look at a few other esters and a few other examples of esters to see if we can name those too. Back in a second. So, using those ideas, let's now see if we can generate another ester through another condensation reaction. And we're just kind of sort of going to step backwards, and then hopefully we're in a situation where we can get a clear idea of what's happening moving forwards. So let's just first of all try and identify the alcohol that we're using here. What is the name of the alcohol that we're using? Methanol, fantastic. So this is methanol. And we can see here that it is the alcohol because of the presence of this characteristic OH group. Fantastic. Can anybody tell me what name we would give to the carboxylic acid that we're using here? Yeah, that's right, absolutely. Propanoic acid. And the reason why we know that it is propanoic is because it contains 1, 2, 3 carbons. Monkeys eat peanut butter shakes. Peanut butter, propanoic acid. Fantastic. And we can see that it's propanoic acid because of this characteristic COOH bond that we can see here. Now, just as we had in the previous example, what we need to recognize is that during the course of this, we get a situation where these parts of the molecules combine to generate water. And again, once again, we call this a condensation reaction. A condensation reaction. Or more specifically, we could call it an esterification reaction. Esterification. We call it a condensation reaction because, of course, we're producing condensation. We also call it an esterification reaction because we're producing an ester. And it's really the ester that I want to focus on here. Fantastic. So with this in mind, let's just think about the product that we're going to generate. So I'm going to draw it first. Okay, so I've drawn the product now. I just want to highlight that this is an ester because of that COOC sort of sequence, that ester linkage that we talked about. There it is. There's the ester linkage that we can see. So this is an ester because of that C to O, and the O is bonded directly to a carbon which has that double bond. But the big question is now, what name would we give to this molecule? What name would we give to this molecule? We've got to remember how we name it. What comes first in the first part? The alcohol first. So we go with the alcohol first. So what is the alcohol that we're using? So how do we convert that methanol into the opening part? What did we do with the methyl? So we call it methyl. Fantastic, methyl. And now we need to identify what the acid is. What did we say the acid was? Propanoic acid. And if you think about the naming that we had, sorry? Almost. Propanoate. Propanoate. So just working this through, the methanol reacts with the propanoic acid to generate this ester. We take the methyl part from the methanol, because it's coming from the alcohol, and turn that into methyl. We take the propanoic, and we turn that into propanoate, and this is the compound that we're left with, methyl propanoate. We're going to look at just one more example. I'm just going to draw them first. Example, we're coming up to the end of the lesson. With this in mind, let's now think a little bit about what we've got here in terms of our alcohol and what we've got here with regard to our carboxylic acid. So who would like to name this alcohol that we've got? Yeah?
Butanol.
It's called butanol. Anything more than that, can we say?
Butan-1-ol.
Fantastic. So we've got butan-1-ol. Great to see that we've remembered to use that numbering system that we talked about just a moment ago. So we've got butan-1-ol here. Anyone want to name the carboxylic acid? Joe? Methanoic acid. Very good, very good. Methanoic acid. So once again, we're sort of going through the thought process associated with this. We've got the alcohol group, which is here. We've got the carboxylic acid group, the COOH, the COOH that we have here. And of course, what's happening during the course of this process is we find ourselves in a situation where we end up generating a water molecule. This, once again, is an example of a condensation reaction, or more specifically, we can call it an esterification reaction. And as we look to construct the actual product itself, we can see that we've got 4 carbons in a row. 1, 2, 3, 4. This carbon here, which is joined to the oxygen, is in turn joined to the carbon, which is down here, doubly bonded to the oxygen. We've got a hydrogen, which is here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogens, all attached here. And hopefully from the diagram, as we've seen in the previous examples, we can see this characteristic sequence of C to O to C. We draw it like that. Now the big question is, what name would we give to this particular ester? Yeah, Emily.
Would it be butyl?
Yeah?
Methanoate.
Absolutely awesome. Butyl methanoate. Fantastic. So great work there. So we've gone through 3 sequences there. The first example, if you look back in the video, you will see we've taken ethanol and we've reacted it with ethanoic acid to generate ethyl ethanoate. We've taken methanol with propanoic acid to produce methyl propanoate. And what I'm trying to do there is to show that the name of the start material is dependent on the alcohol, whilst the second part of the name is dependent on the acid. So flipping that on its head, making it a much shorter carboxylic acid and a much longer alcohol, we can see in this sequence that we end up with butyl methanoate. That's all for today. I'm going to set some prep on Firefly, so if I can ask you to have a look at that on Firefly. We've got some questions that will come from the textbook. We've got one final thing that we need to talk about, which is where we take a diol and a dicarboxylic acid, and what that means is we've got an alcohol group and a carboxylic acid group at the either end, and they can join in a long chain to produce something that we call polyesters. But more to follow on that next lesson.